right? The two lines made with the positive y-axis. So they all come here in that. So let me zoom out for a while. So later I screen again. Okay, so basically, if it helps to visualize, right, you can use the equations that you found just now. In fact, you should use the equations you found just now to help you visualize the locations of the respective tangents. So in this case, you have the tangent at A, the y-intercept is 2A, and the gradient is actually steeper. So that is actually the blue line you see on the screen right here. If you look at the tangent at B, right, the y-intercept is lower, 5 A, and then it has a less steep gradient over here. So from that, you can see that your beta is larger. Your gamma, the beta is the angle that the tangent at B makes with the x-axis, whereas the gamma is the angle that the tangent at A makes with the x-axis as well. But that's not what you want to find. What you want to find over here is alpha, which is the angle between the two lines. So by primary school math, right, you see that exterior angle beta is just the sum of alpha and gamma. So to find alpha, you just take beta minus gamma over here. So of course, since the question involves some tangent inverse thingy, right, you find that the logical thing to do is just tangent it. Okay, you just tangent alpha, and that means that this involves tangent beta minus gamma. And well, what better thing to use than your addition formula, like tangent beta minus tangent gamma over the thing. So of course, for sanity's sake, right, let me just simplify this at the side. How do you find tangent beta? In fact, I kind of went through that, show the working just now, but let's do it again. Right, it's just tangent of the angle that it makes, but this is, since this is pi minus theta, using your tangent properties, right, this is the negative of tangent. And once you have tangent and tangent inverse together, side by side, they neutralize, and that's how you get left the negative root 3 over 8 value. For the same reason, right, you see that tangent gamma is just negative half as well. So once you have them, you sub them into the equation here, and you get this mega fraction over here. So this is actually my way of simplifying. We all don't like to see so many fractions, especially fractions in both the numerator and the denominator. So the trick I'll do, right, instead of combining fraction, I just look out for what is the lowest multiple in both top and bottom. In this case, it's 16. So I'll just multiply top and bottom by 16. And that's how I get to the final form over here. Okay, so once you've gotten the ratio for tangent alpha, right, you just take tangent inverse, and that's your alpha. Okay, question 6 is on the hard side. So if there's any questions, please feel free to type here, okay? Later I'll pause for about 10 seconds more before I move on. Okay, other questions, let me go on to 7. Okay, 7, I think no one asked for it, so I will go study faster. Okay, so part A is actually where it ties in with your differentiation. So how do you know, for cubic equation, right? How do you know what is the impact of F inverse not existing? Well, it's not one-to-one for sure. So cubic equations usually are of this form, right? It's either, assuming the coefficient of x cubed is positive, it's usually of this form, right? So another way that it cannot have a stationary point is this way. So you find that if you compare between the two shapes, right, one of them has two turning points. This guy is not one-to-one. This is not one-to-one. Whereas the second version is actually one-to-one. So we can see that from here, in order for F inverse to not exist, the conclusion to make over here is that there's two stationary points, and that means that the fmx, which is a quadratic expression, right, this equation to be 0 has actually two real and distinct roots. And of course, for quadratic having two distinct roots, you can link it to the discriminant. So just do the b squared, right, minus 4ac. And you conclude that this difference has to be positive, and from there you see that AB is less than 3. Okay, so for part B, well, you are supposed to show that G has an inverse. So, okay, I believe most of you should have done it in the natural way, which is just draw a graph. Okay, and it showed me that it passes the horizontal line test. Right, any horizontal line, k that is real, right, you cut the graph of G at exactly 1 point. Right, so that shows that it's a one-to-one function, and hence G inverse exists. Alternatively, right, you can actually make use of the conditions given by part A. Just to reiterate, part A says what? Part A says that the product of A and B, which is the coefficient of x and the coefficient of x cubed, right? If the inverse function doesn't exist, then this product will be less than 3. Right? But now I've shown you that the product of these two guys gives you a value that is 3. So by the logic, the inverse function actually exists. Okay. Method 1 is a bit harder to see, right? But I would say method 2 is more natural and easier to use. Either way, right, you can show it this way. Okay, so for part 2, you need to show that you can express gx in the factorized form, something like completing a square, but of course this is now in the cubic sense. So of course over here I'm doing the shortcut way, right? But you find that here it is more intuitive. I mean, if it's harder to see, you can do it this way: px plus q cubed plus r. Right. So in fact, just by combining the coefficient, already you see that p has to be 1/3. So you can actually start off with this way. Then you do your binomial expansion. Right. This is x cubed plus 3q square qx square plus 3q square x, and then correct. Then plus q cubed plus r. So in fact, by combining coefficient, you can solve for your q directly. Okay, by combining the constant term after that, you can solve for your r as well. So my way is not the only way of doing it, but yeah, you see this as well. I will say this is a more intuitive way of getting your answer. Okay. Okay, and the purpose of expressing GS in this so-called factorized state is so that you can find the inverse function easily. Right? To find inverse function, you have to make x the subject formula. So of course, you just have to bring your 1 over to the other side. Find that x plus 3 cubed can be written nicely in this form. Okay, if for cube root, there's no need to do a plus minus, right? So you just have to have one answer over here. If it's a square root, then of course you need to do plus minus, the usual way, and then check the domain to see whether you need to reject anything or not. Here no need. Here it's just it's a straight plus. So once you make your x the subject formula, right, you can actually find your G inverse, and that's your answer from there. Okay, the domain of G inverse, of course, is a range of G, and that's how we get to this thing. Okay, so part 4 basically involves the usual reflection property of your G and G inverse, but just make sure that they are symmetrical about the line y to x, and of course if they don't intersect, they better pass through the same point as the reflection of the mirror line. This one I think shouldn't be too bad for you guys. Then of course, to find where GGX equals to x, right? If you recall, one property of your inverse function is that if you take G inverse on both sides, right? Let me just write it over here. GGX equals to x means if you take G inverse on both sides, the G inverse and G, they work like SEM basis, they neutralize, and that's how you can get the fact that Gx equals to G inverse x over here. And of course, that means that you're just interested to find the point where the two guys intersect. And from your GC, right, I believe you can solve for x quite easily over here. Okay, that's for question 7. Okay, moving on to question 8. Question 8 is really a more